Good morning, students. Dear students, as in the previous video, we had discussed about river problem. How a swimmer can easily cross a river. Then, in this river problem, we had calculated the shortest distance, time to cover the shortest distance, time to cover the shortest distance. Then we had discussed about a smallest time to cross the river, and then numericals based on this. These things we had discussed in the previous video, that is part 10 on motion in a plane. Now today, that is part 11 of motion in a plane, we are going to discuss the projectile motion. And which type of projectile motion we will discuss here? We will discuss here the projectile motion on a horizontal plane. The projectile motion on a horizontal plane. Horizontal plane means just like this. This is the horizontal plane, and if a body is moving, if we had thrown a body, this is the horizontal plane. I had supposed this is the horizontal plane, and on this horizontal plane, if a man is standing here, and this man throws an object with velocity v, making angle theta with the horizontal, then what will happen to this body which had been thrown with initial velocity u? If the man is throwing the object with initial velocity u, then this body will move freely under gravity. This body will move freely under gravity, and we assume that the gravity is constant. Gravity is z, means the gravity z is acting over here on that object, which tries to due to which the weight mg of the object is in downward, which tries to move the path of the object like this, because on resolving it there are two components, that is ux and uy. And ux is the component of the velocity along horizontal direction, and uy is the component of the velocity along vertical direction. Ux can be considered as u sine theta, as we had discussed in resolution of vector. That is, it is considered as u sine theta, having acceleration 0, means horizontal direction there is no acceleration, means in this direction the body is moving with constant velocity, that is u sine theta. And uy can be treated as ux can be here u cos theta, and ui is treated as u sine theta. Now look at here, if ui is along this direction and z is in downward direction, we had studied in rectilinear propagation of the objects, if acceleration is opposite to the velocity, then the velocity decreases. So we will take since the motion is in this direction and velocity acceleration due to gravity, so this is the case of retardation, so we take g here for calculation minus g, and up to the highest point what will happen? At the highest point the vertical component of velocity becomes 0, and it will again contains the ux component, that is u cos theta, and after this the body has its component ux component constant in ux component in horizontal direction, and uy, that is u sine theta in downward direction, and then the velocity after this, after reaching here up to this point, the velocity decreases, and after this point the velocity, that is y component of the velocity, increases, because here the y component of velocity and acceleration due to gravity are along the same direction. So this is about the dynamics of the not about the dynamics, resolution in velocity and acceleration, the resolution in terms of velocity and acceleration for the particle which is performing the motion under gravity, when it is thrown with initial velocity u. So let us now start our discussion one by one. First of all, we define the definition of projectile motion. What is projectile? What is projectile motion? So students, first of all, we will discuss about projectile motion. If an object is given initial velocity in any direction, and then allowed to travel freely under gravity, then such motion is called as projectile motion. Such motion is called as projectile. Such type of motion is called as projectile motion. This is a projectile motion, and before that I had explained it also. Now, while studying the projectile motion, we will discuss certain assumptions regarding projectile motion. What are the assumptions? Assumptions regarding projectile motion. Assumptions regarding projectile motion. There are two assumptions. There are mainly two assumptions. The first assumption is acceleration due to gravity is constant. Acceleration due to gravity is constant, and the second one is effect of air resistance is negligible. Means while the movement of projectile, there is no air resistance can be considered. Air resistance can be negligible. Effect of air resistance. Air resistance means the hindrance created by the air, movement of air. During movement, if air is creating any hindrance due to the motion of the object, that can be taken as negligible. Air resistance, these two assumptions we will take. Now, projectile motion in two dimensions. Projectile motion in two dimensions can be resolved in two types of motion. Projectile motion is a two-dimensional motion. Projectile motion is a two-dimensional motion. Always it is a two-dimensional motion because suppose there is a projectile, then there is one component along x-axis and other component along y-axis. And it can be considered as simultaneous superposition of two motions. All things I had discussed of two motions. What are the two motions? First one is horizontal with velocity. That is the component of velocity which we had discussed. If there is velocity v, we are throwing that there are two components. U is the velocity, then ux and uy. This angle is theta. So horizontal with velocity. For ux, horizontal, it can be considered as ux or u cos theta, and here for u cos theta acceleration is taken as 0. There is no acceleration, means in this direction the body always moves with constant velocity, that is u cos theta. And second one is vertical with velocity u sin theta. Second one is vertical with velocity, that is uy, and uy is u sin theta. And in this case acceleration is equal to minus g, because it is opposite to the velocity. Velocity is upside direction, then acceleration is. So we can understand it pictorially as, by diagram, by picture I am explaining you. You can explain it as, suppose this is y-axis, since projectile motion is two-dimensional, y-axis, this is x-axis, and if we are throwing the projectile with velocity, initial velocity u, and it makes angle theta with the horizontal. Theta is the horizontal. Then this is the maximum range, that is maximum distance. This is height, maximum height which can be attained, and this component of initial velocity can be considered as uy, which is equal to u sin theta, and this component is ux, that is u cos theta. This component is ux and that component is uy. It can be treated as the horizontal velocity u cos theta in this direction with acceleration is equal to 0. That is horizontal motion. Horizontal motion plus the second one is vertical motion. Vertical motion vertical motion, and this vertical motion is u sine theta. This is ux and this is uy, and acceleration in this case is equal to minus g. Means this projectile motion can be understood as the combination of ux and uy. So this is the introduction about the projectile. Now we will discuss about certain terms related to the projectile motion. Certain terms related to projectile motion. Terms related to projectile motion. First of all, we will discuss about the trajectory of the projectile. Trajectory of the projectile. Trajectory means path followed by the projectile. It means the path followed by projectile. It is the path, whatever the path followed, we will derive here that what is the path followed by the projectile, or the path followed by the projectile is of what nature. That is, you can define it as a curve joining positions of the same particle at different instants of time. Curve joining difference means clear. Suppose this is here, the particle is in motion at this time initial, and this is the final position. Whatever the curve joining the positions of the same particle at different instant of time is called as trajectory. And there is another term that is called as profile. What is profile? Profile means curve joining position of different particles at same instant. Curve joining positions of different particles at same instant. That is called as profile. If the curve joining the position of same particle at different instant of time, then it is called as trajectory. And if the curve joining the position of different particles at same instant of time, then it is called as profile. So we have not to talk about the profile here. We have to discuss only about the trajectory. So we will now derive the expression for the trajectory or the path followed by the projectile. How can we find the trajectory of the projectile? So from second equation of motion, from second equation of motion, I am drawing here a diagram for your convenience. this is r, this is the maximum range, this is the horizontal range, this is the maximum height, and it is ux, it is uy, and this component ux, this component is ux, that is horizontal and vertical. So from second equation of motion, s is equal to ut plus half at square. For motion along x-axis, for motion along x-axis, for motion along x-axis, the distance traveled, if we are considering the motion at x is equal to x-axis, the component of velocity for motion along x-axis, we will take u cos theta, that is ux, u cos theta into t, and in along x-axis, as I had told earlier, the acceleration is 0, so it will become just like this, as u is equal to u cos theta and a is equal to 0, and from here we can calculate t is equal to x upon u cos theta. Now for motion along y-axis, for motion along y-axis, for motion along y-axis, for motion along y-axis, y is the same thing we will apply for second equation of motion. Y is equal to u sine theta into t minus half g t square. Z is equal to negative because its direction is opposite to the velocity. Now putting the value of t here, we had calculated t is equal to x upon u cos theta. On putting the value here, you can get u sine theta upon into x upon u cos theta minus half g x upon u cos theta whole square, and it will become what? It will become u to u cancel out, and it becomes x tan theta, that is sin theta upon cos theta is equal to tan theta minus gx square upon u square cos square theta. Two is multiplied here, 2 u square cos square theta. This is the equation for the path followed by the projectile. This is the equation for path followed by the projectile or trajectory of the projectile. Now look at here. Look at here. This equation can be seen as y is equal to ax minus bx square. Ax, this thing we had considered a, and this thing we had considered as b. So it becomes y is equal to ax minus bx square, which represents a parabola, which represents a parabola. It means what? Trajectory of a projectile trajectory of a projectile is parabolic. Trajectory of a projectile is, means from here you can say that, you can show that, or you can say that the trajectory or path followed by the projectile is a parabola. So this is all about the trajectory or path followed by the projectile. Now the second term which we will discuss is time of flight. Time of flight. Dear students, look at here, there are two things. That is time of ascent. This is called as time, suppose OA and this is B. So time taken time of flight. So OA, time taken to cover the distance OA, is called time of ascent. And time taken to cover the distance of AB is called as time of this is called as the time taken to cover this distance is called time of ascent, and this distance is called as time of descent. So time of flight can be defined as the total time taken by the projectile to go up and come down to the same level from where it was projected. Means time of flight is what? Suppose the projectile is projected from point 2, so whatever the total time taken by the projectile to go up to this point and come down up to this point at the same level of the point of projection is called as time of flight. Now we are going to calculate the time of flight. Time of flight from first equation of motion. First equation of motion, V is equal to U plus AT. This is the first equation of motion. Now, dear students, at point A, at highest point, the vertical velocity UI component of the velocity becomes 0. Time taken to reach the highest point. U plus AT. Or you can say that since it is the U minus GT, and it is UI, it is Vy, since we are taking Y component, because up to this time, this point, velocity is taken in this direction and acceleration is downward. So Uy is equal to, you know that, U sin theta. So 0 is equal to U sin theta minus GT, and from here we can calculate T is equal to u sine theta upon g. But time of ascent is equal to time of ascent is equal to time of descent. Both the times are equal going up, so total time is equal to twice of t time to going up and t time to going down. That is capital T is equal to twice of t, and from here total time of flight can be calculated as t is equal to twice of t, that is twice u sine theta upon g. Capital T is equal to twice u sine theta upon g. This is the total time of flight. Now we will discuss about the horizontal range. Horizontal range means the total horizontal distance covered by the projectile while coming to the same level. So third point of discussion is horizontal range. Horizontal range, and it is denoted by R. Horizontal range is denoted by R. It can be defined as horizontal distance traveled by the projectile during the time of flight. During the time of flight, whatever the horizontal distance traveled by the, so we have to talk for horizontal, then we can calculate initial velocity as u cos theta, acceleration a is equal to 0, t is equal to capital T, total time is equal to capital T 2u sine theta upon g. So applying using all this in second equation, s is equal to ut plus half at square. So it will become what? R is equal to u cos theta into, this term becomes 0 because acceleration is 0, and t is equal to u sine theta upon g, and it will become u square 2 sine theta into cos theta upon g, and you can write here it as this thing, you can write it as R is equal to 2 sine theta cos theta, 2 sine theta into cos theta. This is trigonometrical formula and it is equal to sine 2 theta. So R is equal to u square sine 2 theta upon g. R is equal to u square sine 2 theta upon g. This is the formula for horizontal range. Now one thing is remaining, that is maximum height attained. maximum height attained by the projectile. Maximum height attained by the projectile. Maximum height attained by projectile. Maximum height attained, this height h we have to calculate, means reaching at the highest point how much height it can be, it will cover. So it is the maximum height from the point of projection of the projectile. It is the maximum height from the point of projection is this, and maximum height is at point A. Projectile. So using third equation of motion, you can calculate it by using third equation of motion. From third equation of motion, third equation of motion, from third equation of motion, v square is equal to u square plus 2as. Since we have to calculate the maximum height, so we have to take all the components vertical. So for vertical motion, at this point the vertical component of velocity Vy is equal to 0 and Uy is equal to u sine theta and A is equal to minus g. So putting these values y, a, y, all these y components, since we are talking about the vertical motion, so it is equal to 0 square u sine theta square minus 2gs, or you can say that this distance is equal to h, 2gh, and from here hence h is equal to u square sine square theta upon 2g. H is equal to u square sine square theta upon 2g. So this is the expression for maximum. This is the expression for maximum height. This is the expression for maximum height. So that's all for today, students. These are the discussions regarding the projectile motion. Go through it and you will understand all the concepts regarding the projectile motion by seeing this video. And in the next video we will discuss some results regarding the projectile motion. We will discuss certain results which are based on the projectile motion, and after that we will discuss the numericals based on the projectile motion. So that's all for today, students. Thank you, students. Have a nice day and take care.